Welcome back, folks. Here's one more video just for some extra practice problems if you need it, particularly some tricky ones if you just want the extra practice, but hopefully it's been going okay so far. Here's example number 4. I have dy dx equals 1 plus x over x times y. And I'm given that y of 1 equals negative 4. I want you to give me the solution of this differential equation with this given condition. When you see that given condition, that means you will be solving for c and give me a final answer with c plugged in. So again, let's see if you can get this differential equation all set to go so that the x's and y's are diagonal from their dx's and dy's. So right now, the x's actually look pretty good because I have this x here and this x here, but notice I'm still stuck with that x. The y's I'm a big fan of. These are totally diagonal from each other. We're good to go. So, some algebra magic. I need to move that bottom x up to the top. How about this? How about dy dx equals, well, 1 plus x. If we bring the x upstairs, that would make x to the negative 1 over y. Well, that makes sense. That actually works okay. Or if you want to think of it this way, it's really 1 plus x over x. That's my entire numerator over y. Either one is fine. I do like this first step here because it's easy to move the x upstairs. And then when I eventually take the integral or antiderivative, that's actually an easier one to look at too. All right, I think I'm set to go. I've got my y's diagonal, yes and yes. And I've got my x's diagonal, yes and yes. Here we go. Y dy cross multiply is 1 plus x over x dx. Integral. Antiderivative of y is 1/2 y squared. And on the right side, well, now this is really hard to take the antiderivative. I can think of maybe doing a u substitution, but remember when we first did these integrals, it was, well, I can simplify by just dividing each piece on top with the one term on bottom. So how about 1 over x plus x over x, which is just 1. Oh, that's a little bit easier. Okay, well, the antiderivative of 1 over x, there's your natural log again, absolute value of x, plus the antiderivative of 1 is just x, and then there's my plus c. Okay, so a little bit of algebra, again, algebra magic, I say that a lot, in order to get the integral that I want. Now let's try to get that y by itself, so I'll multiply by 2 first. How about regular y squared equals 2 ln absolute value of x plus 2 times x plus 2 times c. And again, the c, if I multiply it by 2, it's just going to become another brand new constant, so I'll just call him c again. And then let's take the square root. But first let me write it out so you can see that c. How about 2 ln of x plus 2x plus a new constant c. Square root both sides, plus or minus. How about y equals plus or minus square root of 2 ln absolute value of x plus 2x plus my constant c. Okay. That's pretty good. That's my general solution. But now I need to find out what is c actually equal to. So I'll go back up to the top with my given information. And if this is x and this is y, let's plug it in. Ooh, again, look at my y value. My y value is negative here. And I think about that because I'm in a square root with a plus or minus, so I need to decide which one am I going to use. Well, if y is a negative 4, that means of these two things, that means I'm not going to take the positive, it's actually going to be the negative. Because if my answer is a negative number, that only happens if the negative is on the outside of the square root. So how about negative 4 for y equals, and I plugged in, I think it's 1 for x. Let me double check. Yep. How about the negative square root of 2 ln, plugging in 1, plus 2 times 1 plus c. Okay, c is the only variable left, so let's see if we can get him by himself. Hey, the ln of 1, folks, see ya. And then we can just multiply both sides by negative right away. So how about 4 equals the positive square root? Well, ln of 1 again is 0, times 2 is 0, so I just get 2 times 1 plus c. I want to do a little bit of algebra, maybe square both sides, and c should be 14. Ready? Final answer, guys. Y equals, the solution to this differential equation is the negative square root of 2 ln absolute value of x plus 2x plus 14. And that's the final answer. Again, you can always prove this by taking the derivative of both sides, and you would go back all the way to the original, and it does work. Good job, guys. You got that far. Well done. Proud of you. Why don't we do one more? Here we go. Question 5. How about the square root of y dy dx plus the square root of x equals 0? It's a differential equation. We need to solve for y. And I'm given that y of 1 equals 4. Okay, give me a general solution, and then solve for c and give me the exact solution. Why don't you pause the video and try it on your own, and come back and check. All right, well, let's get the dy by itself, dy dx. So I'll move some things around. I'll get dy dx equals negative root x over root y. X's are diagonal, y's are diagonal. Let's cross multiply. That negative can go either on top or bottom. I'm just going to put on the top with the x. It just works a little bit easier that way. Variables match. Let's do integral, integral. Now remember, these are all just to the 1/2 powers. So if you want to think about it that way, when you do the reversed power rule, this becomes, how about 2/3 y to the 3/2, and then negative is still there, 2/3 x to the 3/2 plus c. Now, if you want to, you could actually plug in the given information right now, and that would be okay. And you can get c right now, and then just keep going. Or like you did before, wait until we solve it for y, and then plug in the values and get c. Either one is legal and be just fine. All right, let's keep going though. Let's do it the way we've been doing before. Let's solve for y. I'm trying to scroll down, but won't let me. There we go. Let's multiply everything first by 2/3. I'm going to multiply by 3/2 actually. How about y to the 3/2 power equals 3/2 times this whole mess, which looks like it's going to be terrible, but it's actually not that bad because 3/2 and 2/3 cancel, and I just get this. Now when I multiply c by 3/2, again, I'm just multiplying by a constant, and that's just going to give me a brand new constant. So really, y to the 3/2 equals negative x to the 3/2 plus a brand new c. All right, last thing to do. It's being raised to the 3/2, so we do the opposite. So let's raise both sides to the 2/3. That'll cancel out these exponents. Y to the 1 power equals, well, I get negative x to the 3/2 plus c raised to the 2/3 power. And I can think about the fact that that's basically the cube root of that thing squared, but right now it doesn't really matter. I can leave it like that. But let's use the given information now, and let's solve for c and get a final solution. Okay, this is happening. When x is 1, I know that y is equal to 4. So I basically have the point 1, 4. Here we go. Let's plug in 4 for y equals negative 1 to the 3/2 plus c, whole thing to the 2/3. Okay, let me move him up here a little bit. Becomes 4 equals, well, 1 to the 3/2 is just 1. So I get negative 1 plus c to the 2/3. This is a little tricky. We're going to have to raise both powers again to the 3/2 to clear out that exponent. So I get 4 to the 3/2. I'll give you a second to think about that without calculator. Equals negative 1 plus c. 4 to the 3/2. You got it? It's 8. All right. I think we're good to go. We got our C value. Let's put the whole thing together from here, folks. The final solution, y equals negative x to the 3/2 power plus c to the 2/3 power. Final solution. So there you go, guys. Notice that we're doing the exact same steps every time, but now that we're given an actual initial condition, we can plug that in and solve for c and get a final answer. And we're all done, guys. That is basically 7.3 separation of variables. Good job.